the topic of this talk is the development of a crawler in search of patent marking information. I want to acknowledge my co-author here, so Gilles Foreste from EPFL, and David Portabella and Professor Hassan Foss from the Chair of Innovation and Intellectual Property from the EPFL as well. So a web crawler, what it does is pretty simple. So you basically just go to the web. The idea is that you fetch documents, and either within these documents you set up some parser in search of certain information that you're after, and you do some archiving. So either you archive the full pages, or just archive, index, whatever information you want to keep and work on later on. Typically what we do here at the moment for this focus crawler is we really target some information with respect to the use of patent for protecting products. To start a crawler, basically you just have to feed a first URL seed list, basically, which is the starting point of your crawler. This can be anything. You have existing list, typically the top Alexa 1 million most visited sites, which is available, or this can be any kind of customized list that you want if you want to specifically crawl certain types of certain domains of interest and so on. So once you fetch a document, one thing you can do in the parser when you parse the document is to identify all the links from this page to other pages on the internet. And then you can feed, the crawler can feed itself with the discovered URL, and then we speak about recursive crawl, and basically the index of URL to crawl really grows pretty quickly. Even on small system, you quickly end up with hundreds of millions of URLs to crawl. Now, to speed up the crawls and to make it more efficient, you can work on the search space or the URL frontier of the crawler. You have several ways to do that. One first, of course, is the URL seed list, so the starting point. And then you can set up some URL filters where you can discard some domains and so on if you want to really specify or if you don't want to go out on certain specific servers. Of course, you can define the depth of the crawler. It means how far you go from the seed URLs where you started from, and typically, in our case, also the type of documents that you want to crawl and parse. If you have a fixed list of URLs, then you just do not, if you don't want to go out of this, then you don't just emit out links. The motivation for this work, this was a law passed in the US that stated that to protect products, patented products, that you didn't have to put anymore the keyword patent or pat plus the number, but now you have the opportunity to protect the product just by putting the keyword patent plus an internet link with further information on the patents that apply to that product. So this is called the virtual patent marking, and it makes now the web a source of information for patent marking, with the big advantage that you don't need to physically access the product to see which patents apply to that product. The relevance of this information, so you want to basically link patents and products. This is of high interest because it provides a link between innovation and market, and then this provides a way to assess the role of science and technology on the economy, so really from research to the products that everybody buys. And the establishment of such a database is really considered as a holy grail in the innovation research. So that's why the chair of innovation and the IP policy from the EPFL basically contacted CITAS at EPFL also to set up such a crawler for them. If you're interested to follow the progress of that project, there is a dedicated website, this IPRproduct.io, which is managed, of course, by the chair of innovations. An example here, so you have a kind of device here, signal splitter. Here you just see that I mentioned that the products may be protected by patents. There's no number of the patents, just a link to the company website, where everything is quite well organized in that case. So you have a list of the products with the virtual patent marking on it, the name of the product, and the patent numbers that applies to these products. In that case, the information is quite well organized. So the goal of the crawler is just to identify such pages. Furthermore, there is, of course, after that, further work to really link products and patent numbers, which is also not a trivial task. So to access virtual patent marking information, you have two choices. The first one, of course, is to crawl the web yourself. And the second one is to use publicly general crawl data sets, which are typically products from CommonCrawl that you can use, where the goal of CommonCrawl is to archive the web. And they put, you can download crawls data sets, which tend to be huge, of course. If we compare both approaches, you have advantages and inconvenience on both sides. If you have to crawl the web yourself, the big advantage is that you get fully independent from external data sources. This is fully customizable. You can fully customize the crawler to your needs, which is quite nice as well. And you can massively reduce, in the case of the focus crawler, you can massively reduce the data set size that you can further process afterwards. The big inconvenience, of course, that you have to build, you have to operate the crawler, and the tuning typically is non-trivial, and every time you move from one server to another, then you will have to play around with all the settings that you can tune for optimizing the machine resources that you have at disposal. For large, massive crawls, of course, you need an ad hoc infrastructure to do that. One important thing is that you need also to handle politeness, that you cannot be too aggressive with the servers that you visit with the crawl. Otherwise, you get blacklisted, and then you cannot get to some servers, and then, of course, you may lack some information. Now, if you look some public general crawl data sets, nice advantage that you don't care about setting up and running a crawler. The data is there, and this is reusable. It means that this is a general crawl, so whatever data you look into this, once you've downloaded it or set up a program close to the data, you can use it for other purposes. In the case of the focus crawler, this is different because you crawl the web in search of specific information, so the data set is smaller, but this is really targeted to one specific application. Inconvenience from this public crawl data set, there are tens of terabytes per crawl, and the crawl runs on a monthly basis in the case of CommonCrawl. You also need ad hoc infrastructure to use that, and you get fully dependent on the data provider of these crawls. The chair of innovation at EPFL has been developing a tool called VPM filter, and the goal of this is to basically to scan data set from CommonCrawl in search of virtual patent marking information. This is based on Spark. There was scaling done by Gilles last summer. So the tool scales very nicely. So you can see that with 4 nodes on the Philips cluster, the EPFL, you can get the processing of 30 terabytes in less than 1 day. And just in a few hours if you use 32 nodes. And you see that the program scales very nicely there. But the big inconvenience in that case is that it took about 3 weeks to download the data. So it was about 30 terabytes of data that we downloaded from Amazon in that case. And this download time and the cost of that is really the starting point, so the motivation for setting up a focus crawler. So that we really want to split, to reduce massively this 30 terabytes to something much smaller. What we do when we download, we fetch a document. The parsing is very simple. It's just a regex. Basically, you just look for 2 things: a patent keyword, so patent, whatever, and a number that should oblige the patent marking numbers. The keywords, actually the regex overall is quite complex and it's quite heavy. So from previous experience, what we did is that the crawler would just only run the regex on the keyword. The idea there is to have more pages with false positive in there, but at least this is much faster. So if we look for both keywords and number, try to identify that within the crawler, this is far too slow. So we split that up, and the idea now is really to have the crawler on the keywords and then to use the VPM filter on an HPC infrastructure to do reanalysis of the 98% reduced data set from the keyword pattern keyword crawl. Few words about the design of the crawler. This is based on Apache Storm. Then we built up into the Storm crawler tools, which are open sourced. And as an index for the URL and for the status of the URL that you want to visit, we used Elasticsearch. What we do, of course, we want to identify pages where potentially you have products related to patents and archive those pages into WARCs. That's these web archive files that you can either leave where you did the crawl, or you can download that to your own infrastructure to further process the data. So basically, the first idea of this focus crawler was to replicate what the VPM filter did. So the regex is exactly the same in both tools, except that they run differently. This is just an example of the data that you get when you identify a potentially interesting page. That, of course, you don't get what you see, a very well-organized page. It can be a real mess. Then after that, the role of this VPM filter, and furthermore, will be to really put the intelligence to relate patents number to products, basically. So for after a development phase, CSCS was kind enough to kind of reserve a server for testing the crawler. So it was nice because it was much kind of nice facility here with big resources for the crawler. But it appeared that the crawler was putting too much pressure on the DNS server, and then started the question of security and ethical concern about the nature of the sites that were visited by the crawler. Because the crawler, of course, I mean, on the web, you know, there's a lot of illicit and pornographic sites and so on. And unless you have a full list of domains that you want to basically not visit with the crawler, then you're out of control where the crawler goes when you start following links. Then we moved to Switched. So Switch, before that we had a couple of discussions with people from the network sides, and to see if the DNS servers pressure that we would put on there was a problem or not, and also if there are troubles with the nature of sites that we would potentially visit with the crawler. And we got the green light from both sides. So at the beginning we just started with a very small server with only 4 CPUs and 6 GB of RAMs. And so they say that a priori there were no concern with DNS servers, and they would be happy to help and debug things in case of troubles. Tuning the crawler, so as I said before, this is not a trivial task. There's no given recipes that you can just set it up, and basically you're using 80% of the resources and everything scrolls nicely. One thing that you don't control at all, almost, is the distribution of the URLs, which links to the basically the design of the fetching bolts that for basically the parts of the program that are in charge of downloading the data, because it's at least in the case of some crawler, you have a system of queues which are defined, and they are typically defined based on the domain names. So in case of, if you have a set of URLs that all depends from one domain, let's say, you will end up downloading all the URLs from a single queue, one thread, one queue. And this is not, at the moment, this is not dynamic. So this is one idea to make it a bit more dynamic. So given the distribution of the URLs, that you adapt dynamically the system, the queuing system of the fetching to make it more reliable. The other things that you have to be aware of is that we follow, well, we do a polite crawl, that we respect robots' instructions. And this can be just applying delays or respecting how many times you leave between two successive download on the same domain name and so on. So this is things that yeah, basically you cannot control in front a priori when before starting the crawler. Of course, you have to play with the parallelism in the topology itself. So the topology is basically the full path between the URL entering the crawler and before you archive the data, if you want to. As I said before, the parser efficiency was a big point why we work on to be really fast, even if we had false positive in the data that we identify. The idea was really to go quickly there. And also there is a lot of things that you're out of control, is that the load on the servers that you visit and so on can vary from every time you start the same crawl, basically you will get different answers. So, recently we did some tests on AWS, so we are scaling test there. So we started with a machine from a similar size that we had at Switch, and we just kept on doubling the compute resources on the machines, and you see that it scales pretty nicely. I would say it's with quick tuning, I think it scales pretty nicely. Of course, we could improve that. In that case, we just started from a fixed list of URLs, so 2 million URLs that we visited. This is extracted from a 56 segments from the CommonCrawl data, the latest crawl. And to get a nice URL distributions there, then we just kept domains with less than 25 URLs and discarded all the domains with too many URLs attached to it. And in that case, even with a small server, you see that in 1 or 2 hours, 2 hours and a half, you can basically look after 2 million URLs, which is not too bad. So this was an older test that we did to compare the VPM filter and the crawler. So basically, we used 28 segments, extracted the URLs that were contained in the WARC files from the CommonCrawl data sets, and just feed that into the crawler to see what was the output of the crawler. Of course, between the time the CommonCrawl did run the crawler, their own crawler, and ours, several weeks have passed, so things are not fully comparable, but it gives an idea of the number of positive match that we had. And also that yeah, basically 80% of the matches were the same on both sides. Just note that here we have a redirection that I did not follow in that case, so this should be closer to 90%. What is more worrying is that it's that pages that were fetched which did not identify the pattern keywords in that case. In the case of the crawler, where it was identified by the VPM filter. So here we have to see whether the page content had changed or if there was some post-processing done or whatsoever. Now if we look at the time to solution from the crawler and the VPM filter, in that case, that was pretty similar. So it was like 1 hour and 40 minutes in both cases. More importantly is the TCO comparison. At Switch, basically you don't pay for the network, whereas at EPFL you pay 3 cents per gigabytes of data. But the compute at EPFL, once you have the data close to you, it's obviously much cheaper than the core at Switch. And you see that typically you have a factor of 2 in that case. For between the VPM filter in red and the crawler in blue. noting that most of the price for the VPM filter was linked to the download of the data itself. Now, for the further development of the crawler, now that we have a prototype which is running on AWS, it's easy to move to bigger resources and so on. So it's running. We can install it very quickly now. The role of the project leader is to find some fundings. To basically, the next step will be to move to a multi-node setup to really get large and or massive crawls. But we need manpower and obviously computer resources to do that. And we also had, there is also a master student project which is open now on it at EPFL, whether you know somebody here who's interested to work on that. And we will also collaborate with Stormcrawler to develop a more efficient indexing queuing system for very large crawls. So the crawler that we developed here, I mean, we can scale it easily. I mean, all the tools that are in the background, they are made for distributed system. It's now focusing virtual pattern marking information, but I mean, you can easily adapt it to whatever else you wanted to do with it. The basic structure is there and it's running. And here, I think the big point is that we should estimate beforehand how much data you want to crawl, or you estimate how long the crawler should run before you can build a decent database relating data products and patent numbers. And within the runs, again, this hybrid solution where we run reduced regex on the crawler, so somewhere in the cloud, reduce massively the amount of data that we can then download to the EPFL premises to further process on the HPC clusters. Some acknowledgements. So we want to thank Colin and Hussein from CSCS for providing this access to that node, that server for some time. Julian Hirsch from Stormcrawler for the very quick support that we get when we have questions about the Stormcrawler in general and crawling. And David Portabella from the Chair of Innovation for the VPM filter, and also Simon Leinen and Jens Christian Fischer from Switch for exchanging on the project. So I thank you for your attention, and I don't know if you have questions on the crawler. Thank you. Yes? How much did it cost to get the data? It took 3 weeks, and it's 3 cents per gigabyte, basically. So yeah, it cost a bit of money. But then after that, as I said, once you have the data on your infrastructure, you don't have to download it again. So and you can reuse it for whatever test you can do.